Okay, well, I think we'll get started. Quick show of hands for everyone here. Who actually has some sense of what Microsoft Fabric is? Anyone? Few people. Okay, so this should be good. Hopefully by the end of this, you'll have a much better idea about what Fabric is. So my name's Andrew May. I work for Leading Edge. I've done a whole bunch of things over the years. Today is actually my 18th year anniversary with Leading Edge, so I've been with a bunch of clients during that time. Started my career more in development, moved to architecture, did some DevOps and cloud along the way, a bunch of AWS, a bunch of Azure. More recently, I've been doing some things in the data sphere. As I mentioned, I've been with Leading Edge for quite a while. We do a ton of stuff. We're consulting. We're based in Columbus, but we've got people all around the country. We've got 4 of us presenting today. I would tell you to attend all the sessions, but a bunch of them are at the same time, so that's not going to work. And we are currently hiring for both .NET and Java developers. So if you're interested, you can come talk to me. We've got a QR code you can scan, or you can talk to any of the other edges who've got lanyards. So as a developer, why should you care about Microsoft Fabric? And I was debating where I should put this slide because I haven't told you what it is yet. But it helps to solve some of these particular problems. So I've been at a ton of companies where they have a single database that contains all their data. Maybe they're a .NET shop, it's SQL Server, they just keep bunging everything in there. They put files in there. I've worked on multiple projects to extract files from SQL Server. Once you start getting to be sort of 500 gigabytes, terabyte, you start really worrying about the size of that database, and performance becomes a problem. You've got different use cases. You've got people using it sort of for reporting when it really wasn't built for that. Maybe you've built a bunch of microservices. You've stored data in different ways in different databases. Maybe it's a mixture of relational and non-relational data stores. And you somehow then need to report across all of them. That's something Fabric could help you with. Perhaps your volumes have just grown to the point that outgrows your traditional tools and your data stores. You need to handle hundreds of gigs of data or terabytes of data a day. Now, it's also true Microsoft is pushing you in this direction. Fabric is the big, new, shiny thing outside of AI. It's probably the thing that's getting the most activity from Microsoft that isn't an AI-specific workload. So certain services are being rolled into Fabric, whether you choose to use Fabric or not. So you may just be pushed there. And then, inevitably, AI does factor into this. You need data for your AI workloads. If you're wanting to present something to your customers, whether they're internal or external, and you want to connect that up to your real business data, do you trust attaching that directly to your production database and giving it full access to everything? It's probably not a good idea. You want to work on a curated data set that just contains relevant information. So now I've given you some of those reasons to use Fabric. Let's talk about what Fabric is. Now here, this is from the latest FabCon conference, and they're promoting it as a tool for AI transformation. But it's really a lot more than that. AI is just one factor in here, but it's certainly like the big buzz one at the moment. So this is split into different components. The groupings are a little arbitrary, not necessarily how I would call them, but we're going to walk through these one at a time. Under everything is the storage layer, and that's OneLake. Now, OneLake is really just blob storage, object storage, with a hierarchical file system and permissions added in. The nice thing about OneLake in the use of Fabric is you don't need to care about it most of the time. It's just there. Everything's in OneLake, different services in Fabric, because they all use that shared OneLake, have access as long as you've granted them the necessary permissions. You're not worrying about, oh, how do I network connect these two resources in a private way or anything like that. Data Factory, some of you might have used Azure Data Factory as a sort of ETL tool within Azure. This brings a lot of that functionality into Fabric. In fact, it's built on some of the same code base. And recently, it got more parity with some of the functionality that was in the Azure version. But it also adds a bunch of other things. So in addition to pipelines that can process your data, we also have some neat features like copy job that makes it really easy to synchronize data between one source and another, and mirroring, where you can pull in entire databases and have a copy in your OneLake and therefore accessible to your Fabric tools without really having to configure a great deal. So that can just go off, maybe change data capture on the database and then push all the changes across. So you've got a near real-time copy of your original data source. Analytics covers a bunch of, it seems like a wide range here. It's data engineering, so this is the processing of your data for various use cases. Data science, so think more traditional machine learning workflows. And then data warehouses that are the foundation of reporting. So it's kind of going from your ingestion of data all the way down to how you consume it at the end. And this is the area we're going to talk about the most. Databases, a lot of you are familiar with SQL Server and Azure SQL, its Azure equivalent. You can run SQL database in Fabric that's essentially just Azure SQL, but even more managed for you. It's just serverless, spins upon demand. There's some benefits to that. The data is immediately available in OneLake for other applications to consume. So there's some reasons you might consider this, although I don't think everyone's going to rush to replace their Azure SQL instances with SQL database in Fabric. You also get Cosmos DB. Again, this is a flavor of the Azure service, but in a Fabric sense. Real-time intelligence. Maybe you've got IoT data coming in at a rapid rate. You've got clickstream data. So this is all things dealing with data that's coming in real time, and you want to process it in real time and display information about it. So an event stream captures that information. You can store that data in event houses. Now, if you've ever used Azure Monitor, things like Application Insights, and you've used Custo queries against that, this is a lot of the same technology under the hood. So it's time-based data, and it's designed for querying in that way. You can have real-time dashboards, so if you want to see orders coming in live over the last 5 minutes and summarized, all that's built in. And then Activator is used within Fabric as a way of triggering things off an event, and it's sometimes used as kind of an event-based trigger for calling other services. IQ is the new hotness that they talked about a lot at FabCon just a couple of months ago, although it was actually released sometime last year. This is the idea of making your data more intelligent. So at the core of this, we've got ontology and graph. So an ontology is being able to describe your underlying data in more business terminology. And that way you can build data agents and point them at your ontology, and then they can query the underlying data, understanding your data model. So you've created a mapping. Now, this is very much in preview. Some of the functionality here doesn't work great. I tried to demo some of it. It's also rapidly evolving. It being in preview, they could change some of the functionality significantly. And then a lot of people will be familiar with Power BI. Power BI is one of these services that they rolled into Fabric and essentially pushed people into using it within the sphere of Fabric. You can still buy Power BI separately, but you can also buy Power BI via Fabric now. So if you're not familiar with it, you start with semantic models that are kind of similar to those ontologies in that they sanitize your data model in a way that you can build your reports. And then you can build your reports that your business users use, and then maybe you also embed reports in websites for your customers using embeddable reports. Now, how do you pay for this? How does it all work? So the thing you need to understand here, unfortunately, is Fabric capacity. This is what's used for all your compute within Fabric. This starts with capacity units, and a capacity unit is essentially a unit per second, which is a weird way to think about anything, because we don't think about everything that goes on in every individual second. You pay in terms of SKUs that start with F2s, go all the way through to 2048. So think of that like an F2's 2 capacity units per second. There is some averaging over time, so it's not like use it or lose it on a per second basis, but it may be use it or lose it on an hour basis for certain services and 24 hours for other services. It's a bit hard to tell what's going on. There are metrics apps to try and tell you what you're actually using, but it's not great. It is also expensive. So here we got some example prices, $263 a month for the cheapest. That's a lot more expensive than a lot of Azure services, going all the way up to the mouth-watering $270K for the highest SKU. And a lot of organizations may choose to buy multiples of these Fabric SKUs because you may want to separate your dev and your production workloads from each other, or you may want to separate ETL from reporting for various reasons. You do get a big discount if you can reserve for a year. So 40%, that's not a bad thing. And then if you're paying for an F64 or above, you get free Power BI licenses. If you're smaller than that, you're going to have to pay separate Power BI licenses for people who both build and use reports. Everything is concurrently consuming and competing for these capacity units. So there are issues where you may run an ETL job and it starts throttling every other thing, to the point where because of this smoothing, your ETL could break all your business reports for maybe up to 24 hours. There are horror stories like that. That's not great. They've started building in more tools so that you can control Fabric capacity and say, oh, this ETL job can only consume 70% of my capacity units, so it can never completely break my reporting. But it's something to be wary of, and also the reason why people split up these Fabric compute so that they can prevent those kind of throttling issues. Now, given this is a developer conference, most of you aren't going to go out, if you want to try Fabric, and put down $263 a month. So the good news is you can get a free trial for 60 days, and you often can just keep getting more and more free trials by switching to different users. I will note you can't use what it considers a personal email address for getting a free trial. So if you've got a Gmail account and you maybe create an Azure account with a Gmail account, and then you try and use that in Fabric, it's going to reject it and say, please enter your work address. If you have Azure, there's a simple workaround then. Your Azure account will have a free Entra tenant. It will have an onmicrosoft.com domain. You can create users in Azure, in Entra, that are members of that domain, and then you can register for a free trial with those. And each time that trial expires, you can create a new user and a new trial within the same organization, and then you can share the data from your previous trial. So I did this as part of preparing this presentation. I got an F64. You either get an F64 or a 4. There's a big difference between the two. But for one person, an F4 is generally going to be fine for just experimenting. And the region it picked was also kind of essentially where they've got the most available capacity. Let's talk a bit more about data engineering. A lot of this is based around something that's being called the lakehouse architecture. And it'll make more sense as we go along through this presentation. Some of the fundamentals of this are a bunch of open source technologies, Delta Lake, Parquet, processing things with Apache Spark, which you write code in Python or Scala typically. Within Fabric, we have a tenant that's a one-to-one mapping with your Entra ID tenant in Azure. You have a collection of workspaces that are your shared resource, like workspaces hold a bunch of shared resources. So you decide how you want to split up your data and your processing and put that in workspaces that you can then share with others. And then within that, you create lakehouses that contain delta tables and files. Now, a delta table is essentially a table that looks like SQL, but under the hood, it's a Parquet file or a series of Parquet files. You can perform ACID-compliant operations on that single table, but it doesn't have common things like primary keys or indexes. It can be performant for certain types of workloads, but not for everything. It's not going to be a replacement for your SQL Server for everything you might do, but it can be useful in these kind of data engineering architectures. And then you're typically processing this data with Apache Spark. So let's see some demos. Hopefully the videos work here. I'm going to speak over them, so we're not going to have audio issues, but it'll hopefully give you a better idea of how all this works. So I'm going to start off in my workspace. Yep, that's working. Which everyone gets a my workspace. And then I'm going to create a new workspace. I'm going to call it Stir Trek because it's for this conference. And then I'm going to pick my Fabric free trial. And that's important because that turns on all these data engineering features. Then I'm going to create a lakehouse. So we said this is a lakehouse architecture. That's the first thing I'm going to do. I'm going to call this taxi data because this is going to pull in some sample data about taxis because it's a lot easier to demo this with someone else's data than trying to generate this myself. So we pull in some sample data, and we pick this New York taxi data set. Now this is interesting in that it's got trip data for taxis in New York for a bunch of different years. It's going to show me that I've got these different tables. Essentially, it's just one table per year full of trip information. If I expand this, I can see it looks like a normal table. It's got columns, they've got data types. But if I say view files, behind the scenes, I can see this is actually a Parquet file. It's 262 megabytes. It's compressed in Snappy format. There's a couple of other folders here. What happens over time as I update this Delta table is it will create additional Parquet files and a Delta log to keep track of those changes. You can actually roll Delta tables back, but then you have to vacuum them and to compact them again, and you lose that history. But it means that it's a very transferable format. This Parquet file can be consumed by lots of different tools. So now I've got some data into a Delta table. What do I want to do with it? I want to do some data engineering with Spark. So I'm going to open up a notebook that I already created, and I'm going to query that information. This is a Jupyter notebook. If you're familiar with data science, you might have well used this. Very commonly used for things like Python and R. I've got markdown cells where I can annotate my notebook. I can run all of these cells together in sequence, or I can run the cells individually. You can even run them out of order if you want, which is interesting and may not give you the results you expect. Very quickly, this ran in a second and said my table has 11 million records in. That's quite a lot of data, and that's pretty fast to count a whole table. I can then do some kind of summarization across those 11 million records, and that took 2 seconds. I can do the same thing writing a SQL query, and it executes and gives me the same results. So I can switch interchangeably between this kind of Spark flow and a SQL flow. Now, the real power from Spark comes from its distributed nature. If I expand the resources here, you can see that it ran across multiple executors. So we've been trying to do things like this with big data for years. Some of you might have used Hadoop in the past and had to deal with all the hassles of trying to run MapReduce and deploy jobs and look at the results, or maybe you used Hive or HBase and these things on top of a Hadoop cluster. It was painful to use, took a lot of setting up, often had a lot of cost involved with it. But here I've got essentially big data from a few clicks, and I can process and get results in seconds. So it's very powerful how Spark has evolved this big data processing. So a bit more of a look at what some of that code was doing. So DF is a typical abbreviation for a data frame. And Spark data frames are really the core of all of this. And if you come from a C# background and you're familiar with LINQ, some of this really isn't that different. So in these two examples, we're doing a where to filter the data, a select to pick out particular columns, and in this case also generate an extra column, and then some sorting. The syntax looks very similar, and in many ways the execution is the same, because in both cases they execute lazily, and only when you say, I want the data at the end of it, does it decide the processing it needs to do. So in the link case, if you're using a link for, say, entity framework, based on that select, it's going to figure out, oh, I don't need to pull back all the columns in the database, I only need to pull back some of them. In the data frame case, the same is true. If you've got that million records and you're only going to end up summarizing it off a few of those columns, it's going to efficiently only fetch the data from the Parquet files that it needs, and Parquet is structured to be efficient to pull back by column rather than row. Now, as developers, there's certain things we expect from our tools. And often these tools in the data area didn't really have a lot of these things. Things like Git integration, we think of as a given, but if you were using data tools over the past few decades, it was very much an afterthought, and even if it did integrate with Git, what it put into Git was often some weird binary format that you couldn't read. With Fabric, the files it puts in are typically large JSON files, but they are reviewable and they are readable. You attach a Git repo to a particular workspace, so again, that's that collection of collection of resources that may contain your notebooks, which have your Python code in, may contain a lakehouse definition, or a bunch of other resources. That gets committed to a branch in Git. You might commit it to a developer branch and then merge that in, and there's some functionality around that, and previewing changes and pulling and syncing. There's also a bunch of ways of doing CI/CD. So typically you're not going to be editing your Fabric resources in your live production environment, I hope. So you want to work on them in a development environment and getting them into production somehow. And that's typically done with Git at the core of that, but there are different approaches to synchronizing the different environments. There are even deployment pipelines within Fabric, although Microsoft, having built this, now no longer seems to recommend that you use them. You can also use pipelines within Azure DevOps or GitHub Actions and push things that way. And then it's becoming popular to use this Fabric CI/CD library, and this is now Microsoft's recommendation. So another developer feature is obviously, the ability to use developer tools. So you can open this up in Visual Studio with some Visual Studio Code with some extensions. Here I'm already signed into my Fabric environment, and I've already got the extension in, so it didn't prompt me for any of it like it did the first time. But I can see all my resources in my workspace, I can see my notebook, I can edit it, and the changes I make here will be reflected directly within Fabric once I save it. I can also connect to the Fabric kernel, as they call in, it's kind of Jupyter terminology, to execute things. Now, interestingly, this is considerably slower running here, so I don't know quite the division of compute, how much this is just network traffic making it slower, and how much it may actually be doing some of the centralized portion of the computing locally. So this took something like 20 seconds when I ran it this time. Other times I recorded this, it was closer to 10, but it's much slower than that 1 or 2 seconds that we saw in the Fabric environment. But I can run pretty much the same queries. Now, because I'm in VS Code, I've got a greater range of tooling. I've also got a dark mode, which is important to me. So I've got chat here, and it's pre-configured with, I guess, a custom skill that understands Fabric. So I'm going to prompt it to add in some code into a data cell, into a code cell, so that I can save off some of that summarized data I created into another table. And this is really what you're typically doing. You're not just running queries and viewing them, you're processing data, transforming it from one form to another, and saving it off somewhere. So I put in a prompt, it's going to go off and think. This little bit takes a while, it talks to a couple of MCP servers, which it prompts me for. What I'm trying to do is use a merge. And a merge is a common way of saving data into these tables, because once I already have data in there, I don't have primary keys. I need to sort of say, based on what I want to be the key, merge in data. If I've got new records that don't match the key, insert them, otherwise update them, maybe delete ones that don't exist. But it's also going to add in the code some checks to see if the table already exists. If it doesn't, it's just going to overwrite and put it straight in there. Pretty basic, standard stuff when you're writing PySpark. But this takes quite a while to figure that out. Now, I will say this experience that I get with Copilot here in Visual Studio, you can now get something very similar within the Fabric editor on the web itself. It's greatly improved in the last month or so. But if you've just got a free trial, you don't get that. It's a paid feature to have the Copilot. It also, I believe, consumes your Fabric capacity units. So if you're using the agent too much inside the Fabric, especially if you were doing it in a shared capacity that you share with production, you might actually be causing problems with your performance. So here we got the code generated finally, and like I said, it's essentially check, does the table exist? If it doesn't, just overwrite the data and create the new table, otherwise do a merge. So all of this typically fits into something called a medallion architecture that is tied in with this lakehouse idea. It's called a medallion architecture because you have bronze, silver, and gold, where bronze represents essentially your original source data pretty much in its original format. This may be data that comes from different databases, from files, perhaps your customers send you files, sensor data, or all kinds of things. It might be a bunch of Excel spreadsheets that the business users use. You can either shortcut to it, which is nice because it means your data doesn't actually get copied, it just gets read transparently from one lake, or you can copy it, or you can mirror it in. But typically it's going to land in that bronze lakehouse, which, like I said, was a collection of tables and files. And in this bronze layer, you may choose to keep that as files and just reference the files directly. You are then going to transform it into a silver layer where it's a cleaned up version of that data, but it's shaped somewhat similarly to that original data. So if you had essentially 10 tables to start with in bronze, you might have 10 tables in silver, but they would be sanitized, you would have thrown out bad data, you would have had consistent typing and naming. And the processing as you go between that will often use Spark notebooks because it's an efficient way to process these large volumes of data from different formats, from reading Parquet, JSON, fixed length, whatever it might be. And then you use those different ways that you saw to save off data to the tables into this silver lakehouse. Now, you could do this entirely without Spark, and you can just use data flows or just your pipelines to do some of that manipulation. But this is the more code-first approach, and is the most efficient way with dealing with large volumes of data. Then from your silver layer, you go to a gold layer, and this is where your data is prepared for your more business workloads, or in this AI world, that business workload might be an AI agent that's looking at that sanitized version of your data. So here you're more joining and transforming the data into the form that you want for the gold layer. Now, with a lakehouse, you can always query this using SQL in a read-only way using what's called a SQL Analytics endpoint, where you can write T-SQL. It's very much like what you would write against SQL Server. It will perform differently because of the lack of indexing and the inherent differences in how the data is stored, but it will give you somewhat predictable results. Or you could directly have Power BI talking to a gold lakehouse, and we'll talk about that in a second. Within the gold layer, you often have this choice. You can stick with strictly lakehouses and delta tables, or you can use a data warehouse, because that's also available as a service within Fabric. In both cases, you may well choose to use a star schema. Star schemas are not a new thing. They've been around for decades as a primary way of representing data for reporting use cases. Essentially, you have dimensions and facts. Dimensions are things like products or dates or employees, and facts are things that happened that typically contain mostly numeric data that link to products or whatever it might be, the dimensions via an ID. The idea is to keep these fact tables fairly lightweight because you could have millions of these records and you're wanting to do summarizations against them in really efficient ways so that you can quickly generate reports. Now, if you stick with a lakehouse, it's not necessarily tuned performance-wise for this kind of architecture, but if you go with the warehouse, it is. It's very much optimized for using a star schema. Now, at the end of the day, why did you do this? I mean, AI is obviously a possible reason, but reporting is one of the big reasons. So let's say you're using Power BI and your company wants some reports. Typically, if you look at this example from the documentation of a report, all of these things are summarizations. Maybe they're summarizations based upon date or geography or some other different measure. So you're typically splitting this data up based upon one of those dimensions and summarizing. So you're not displaying the individual records, you're always grouping things together. And that's why it's important that that fact table is lightweight and has measures that can be easily summarized. Traditionally, you had two basic options with Power BI. You could either import all your data into your Power BI semantic model. You did a ton of processing to query everything and put it in a big file, essentially. And then you reported off that, and you got good performance because you'd already pre-aggregated the data. Unfortunately, that meant your data was immediately stale, and as you sort of decided I needed to refresh this every 24 hours, you then took another hit of processing and data utilization. You also had direct mode where it could query off, but then whenever someone runs the report, they're getting a performance impact. Maybe you hook this up to your production database and they run a report and everything goes slow. Direct lake is essentially querying one lake directly and getting an efficient mechanism of getting your data back up to date without having that impact on your original source systems that this is disconnected from. Now, what does some of that look like? Time for another demo. This is actually from the Fabric IQ demo, where we've got a number of dimension tables and a fact table. We're going to pull those into a semantic model. That's in a second, so we move over to the semantic model. This is the same three tables, two of the dimension tables and the fact table, but I've cleaned it up a bit for our business users by renaming the tables and by hiding some of the ID columns that are used for the joins that they don't really need to see in their reports at all. So you can see we've got certain things on our fact here that it's showing it can do summarizations on. And then I quickly pull up a report, just dragging some things around. It's doing those aggregations by different dimensions. These two widgets are linked so that if I click on one widget, it's immediately reflected in the other. So it's quite a powerful tool. You can see how people can easily build reports this way from a business perspective. So I did all of this as part of the Fabric IQ demo, only to realize that at the end, when you want to create a data agent, you can't be using a Fabric trial. It's not really made clear anywhere, which was kind of frustrating. Now, if I want to do Fabric IQ, I'm going to start with an ontology. That ontology is often built from a semantic model, so you've already predefined some of these relationships, but then you can enhance it, or you could create it directly from any item in your lakehouse, or a range of items in your lakehouse. Currently, it only supports certain types. That ontology is describing in business terms the relationships between your data items, and then behind the scenes, it builds up a graph instance that you can then query the graph, and then you can attach a data agent to that graph model and ask it business questions and get back business answers where under the hood it's run queries against your data model, which it understands much better because of the ontology. Then in theory, this can be exposed through the various different IQ tools, Fabric IQ and Foundry IQ and M365 IQ, I think, or I don't know the terminology, it's confusing and it changes every day. But the end goal is that you can expose to your business agents that can query this data, also pull in business documents and whatever from Office 365 and give them the information they need. So that covers a lot. At the end of the day, How do you decide whether Fabric makes sense for you as a business? Now, I've split this into decisions you might make as a developer or if you're an architect, because obviously you have a different level of agency in this depending on which you are. As a developer, you may simply have no choice. The service you're using, maybe you're a Power BI developer, it's been pushed into Fabric, you're using Fabric. Good luck. They've also announced things like at FabCon, they announced a database hub that's going to be a monitoring tool for all your databases, whether they're on-prem, in the cloud, or in Fabric. Guess where that's going to be? It's going to be in Fabric. They haven't actually explained any details about that, whether it's going to use capacity units or anything like that, but good luck, it's going to be in Fabric. If you are doing ETL and you want to do a programmatic option, you don't want to do drag and drop, you're dealing with high volumes of data, Spark is a great way of doing that. It performs very effectively with large volumes, millions of records, it doesn't break a sweat. But it is a big, expensive platform, so as a developer, unless you're a very small shop, you may not be the one making the decision that, hey, we want to spend $8,000 a month on an F64. It's a big cost. It is an alternative approach to managing and working with data scale. It's not the only one. There are other options out there. If you're happy with what you're doing at the moment, Fabric might not be the right option. But if you find that your current tooling is straining under the load as your business grows, the volume of data you get in keeps increasing, you've got some bespoke solution that just can't hack it anymore, this might be a way to go. Now, if you're an architect, again, Microsoft is pushing you in this direction. They're sending you white papers, they're promoting it as the option, and they're saying, look, all of our data tools are now in Fabric. Use them all together and it will be seamless, which is true to a degree. The sense I get, and I'm no expert in this, is that a lot of people still prefer Databricks for data engineering, and this is where a lot of that lakehouse architecture and these toolings kind of came from, because Databricks was founded by the people who originally wrote the Spark project, the open source project. There's a lot of overlap with Snowflake, so a lot of businesses have moved all their data, big data, into Snowflake. You can do some of this data processing there, so you may choose to just stick with Snowflake. But they're also integrating Snowflake tightly with Microsoft Fabric, so you can have Snowflake store all your data in one lake, or have your data catalog in Fabric so that you can use Snowflake directly without even really knowing that it's in Snowflake. So there's ways to do hybrid situations. I will say, like I found with IQ and trying to demo some of this is half-baked. Even in the services that are considered more stable, we've hit issues that are just kind of, you wouldn't expect. Some of the CI/CD functionality, for example, can accidentally have your production workloads talking to your development data if you're not careful about how you manage it. And those kind of things, to me, are a big deal. Okay, I pretty much run out of slides now, so I'm going to do some time for questions if anyone's got any. And if you don't want to talk to the room, you can always come up and talk to me directly, or I'll be around the conference.
I have one for you, Andrew.
Sure, James.
What advice would you offer on selecting the proper SKU or doing sizing for your organization?
Oh, this is the right. So I think the question was the right SKU, the right size for the Fabric capacity. Is that right?
Yes, that's correct.
Yeah. I mean, I think my advice there, given the cost, is to start as small as you can. The general rule of thumb I've heard from others who know far better than me is start with something like an F4, maybe an F8 if you have different teams working on it. Monitor it and see how you go from there. As you move to production, you may need to think about splitting out separate Fabric capacities so that your production workloads aren't being interrupted by your development workloads. But otherwise, keep things small because it's an expensive system. Don't immediately jump to an F64 just because you get free Power BI licenses. Power BI licenses aren't that expensive to buy individually. see one further back.
You talked about Python, PySpark. One of the other options that appears to be a new option is Spark SQL, where you can use T-SQL between lakehouses. But it seems to be a new thing. Do you have any experience about when it would be okay to continue using something like the new Spark SQL versus PySpark?
Sure. So thanks for the question. Yeah, the question was essentially, when would you use the Spark SQL functionality to access your data rather than directly using PySpark? So you can think of that in terms of how comfortable you are with one technology versus the other in many ways. If you are much more comfortable writing T-SQL than you are writing Python code, then being able to select and manipulate your data using SQL and then essentially just persist off the data frame that you get back from that can be much more comfortable for someone who thinks in terms of SQL first rather than code first. At the end of the day, I couldn't say whether the performance is identical, but it is in the same ballpark because under the hood it's all being translated into Spark code, which actually all runs in Java unless it's one of those sections that they've optimized and may be running as Rust or something under the hood. Any other questions, or should we call it there? One more? Okay. So the question was around people who have existing Power BI licenses. So I don't claim to be an absolute expert on this, and licensing with Microsoft is always complicated. My understanding is that those individual licenses that I think are tied into M365 for people who are writing and viewing reports, those premium licenses are still a thing unless you're getting at least an F64 when that gives you those free for your organization. So if you have a ton of people editing reports, you can add up the cost of those Power BI licenses, and it could be the decision between going for an F32 and F64 because you get those free licenses. On the more like compute side of things, you can still buy dedicated Power BI. I think they're P SKUs for just Power BI capacity, but you can kind of swap in Fabric SKUs instead of those. So I hope that answered the question.
Yeah, one follow-up, I guess, is you talked a little bit about the direct query version of Delta Lake or data lakes. How does that compare, like, from a performance standpoint to like a pre-aggregate, tabular view of those sorts, or like you can just direct query on top of like a snowflake?
So the question is comparing direct query as a mechanism for getting your data in more traditional Power BI to the direct lake mode where it's querying the lakehouse. I think the answer honestly is going to be it depends. Microsoft will say it uses the same query engine behind the hood, depending on if you imported data into Power BI versus using direct lake. So it's supposed to be super efficient. But it's obviously going to depend upon exactly how you've structured your underlying data source, if it's a data warehouse versus a lakehouse, you're going to get some differences in performance. I think there is still some caching that goes on that's kind of intelligent caching that may speed things up. So I think you'd have to really try it and see with your particular workload and figure out, is the performance good enough with direct lake, or do you want to import? It is expected to be faster than direct query would typically be for the same type of things. Okay, I think I got time for one more if anyone's got one. Otherwise, we'll call it there. Thank you, everyone.